we'll go with that, and we'll see where we go. So we got the good Norwegian flag up there, and you've got the coastline, which dominated Norway. Oops, I forgot. Good. So, for those of you who can't remember where Denmark happens, where Norway is, here is Denmark, Sweden, Norway, Finland, and way up here is Svalbard and Spitsbergen, and I'm going to mention that in the next slide. And you will actually see some photos from that country, that part of Norway, because Norway governs it. And so, just to give you a little, here's Oslo, the largest city. I'll show you a picture from there. Bergen. And Trondheim, that's the second largest city, the third largest city, and then my great-grandfather's from Tromsø, so I got at least 3 photos in there from there, and my great-grandmother is from Lillehammer, which is over in this area here. Notice the difference in size, you know, the distance between Oslo and Bergen, because I will use that when I talk a little bit about transportation and the roads and how they deal with getting around in this incredible country today. And then way up here at the end is the North Cape, and I will show you some pictures of that. And then all of these indentations that you see in here are all fjords. And an absolutely wonderful area. And last year, Nordic Northwest sponsored a trip to the Hurtigruten, the boat that went up and down the coastline and in and out of those. I'm going to show you some of those particular areas there. So here is Norway, but I wanted to show you Svalbard, which is the closest land. It's an archipelago, closest land to the North Pole. And it's run by Norway, but at the same time, other countries can be there, and about 30 other countries are there. Russians are the number 2 largest ones in that particular area. And I'll show you a little bit about that because it is absolutely wonderful. So the country of Norway is over 125,000 square miles. Oregon is 97, so it's about another 25% bigger than Oregon is. It is 1,089 miles from the top all the way down to the bottom. The widest part is only just 250 miles, so it's a long and skinny country that you've got. But they have 2,000 miles of coastline, which dominates everything. But 80% of the country is mountainous. And 80% of the country is over 1,500 feet in elevation. And so that affects the way, the life of the people. They have over 5 million people. Here in Oregon, we have over 4 million people. So they're slightly bigger than us in the population. But in Europe, it's the most sparsely populated country in all of Europe, with only 33 people per square mile. And so Oslo is the largest city, then Bergen, then Trondheim. Being a university professor, I always ask how many universities are there, and so they have 4. And they have Oslo, Bergen, Trondheim, and Tromsø as the major ones there. So, many of you have been to, here's Oslo, absolutely big, beautiful city that is there. I'm throwing in this because my favorite place in Oslo is Vigeland Park, with these incredible statues of showing human emotions. And if you haven't been there, I encourage you to go there. It is just absolutely wonderful. One of my favorite places there. Bergen, oh my God, what an absolutely beautiful city along the coast there, and absolutely wonderful, as is Trondheim. And so 3 big, beautiful ones. And then, where my great-grandfather is from, Tromsø, way up at the very, very northern part. And I love it so much, I got a couple pictures. There's one in the winter time there too. It was fun because there's an old part of town, and they had the ages of all of the buildings on it when I visited it the last time. And I knew that my great-grandfather would have been there. The North Cape, which I will show later, I still haven't been there, but my God, is that an absolutely gorgeous place, way at the very, very north. It's the northernmost place in all of Europe, and is absolutely beautiful. There's one of the settlements that is there. And the next picture is just out on the coast, and you can see there, absolutely beautiful part, way above the Arctic Circle. Now this is a geological map of Norway. And I'm not going to bore you with all of the different ages of everything, because everything is really, really old. This is some of the oldest rocks that are found on the face of the earth. And many of these rocks are what we call Precambrian and then Paleozoic. And so they are way over 250 million years old, and actually most of them over 400 million years old. So they're old, and then what has happened, well, then we'll get into the characteristics of them. So they're mostly gneiss schists and granites that we have got here. Now, in order to get to where we have, I have to go back to basic 101 geology. The whole Earth is moving. Wherever we are, right now, we are moving 2.5 centimeters in a westerly direction. And the reason is magma is continuously coming up around the Earth at what we call ridge systems. And there are weaknesses in the crust, and then they are rising up to the surface. The magma comes up, and then it solidifies. And then more magma comes up, and it pushes the crack to the sides. And the rate of magma coming up will dictate how fast the plate, this is a plate, is in both of these directions, moving away from that. And then they will keep moving until they run into another plate, and then at that point you will have subduction. One will go down underneath the other, melt, and then come back to the surface as a chain of volcanoes. And so we have plates that are moving all over the face of the Earth. So here in North America, we are moving in a westerly direction. We're on the North American plate. Here's the South American plate. Here is the European plate moving in that direction, and the African plate is moving in that direction here. And they're all moving away from the mid-Atlantic ridge. And then we have the Pacific plate that is moving up in this direction, being destroyed as it goes down underneath Alaska and over this area here. And so the Earth is divided up into plates, and it has been divided up into plates for over 3 billion years. And the plate that is up here in Scandinavia is part of one of the oldest plates that was around. Here is a map as all of the plates came together 400 million years ago. And so here you can see there's what was a tiny North America, there was South America, there was Africa, and Baltica, that was Scandinavia. And it had been around for 2 billion years. It was crust that was very, very old. The sedimentary rocks, the volcanic rocks, everything had been metamorphosed into changed rocks in the future. And then Siberia was over here, China is down here. And so what happened is they all came together. All those plates came together 400 million years ago and formed a supercontinent that we call Pangaea. And as they came together, all of the ocean that was in between those plates was uplifted to form a great chain of mountains. And it formed the mountains that we have in Russia and then also all the way through Scandinavia. And then what happened after that occurred, all those mountains eroded down. That was 400 million years ago. And they eroded down to what exposing the rocks today. Those mountains were what we call the Caledonian orogeny. There in Scandinavia, as it crashed into Greenland, and it created those mountains. And so what we see today, and there's Baltica. So this is the map of the world today. There's Baltica. There's the North American craton, the South American craton, etc. That we had there. So they're old rocks that have been around for a long period of time. So I've summarized the whole history on one page. And that is from, and so BA is billions of years ago, MA is millions of years. And so you had all of those rocks forming for the up until 400 million years ago. And then and all different types, that would form Baltica. And then they all came together in the Caledonian orogeny, forming the great mountains that we had in that particular area, squeezing and forming mostly metamorphic rocks. And I'll show you pictures of those in a second. And then from 4 million years ago, 400 million years ago until 2.6 million years ago, the beginning of the glacial period, all those did was just erode down, get smaller and smaller and smaller. And those large mountains that may have been up to 10, 12,000 feet in elevation, reduced way, way down to 8,000 at the maximum. And then the glaciers came in. The glacial period started 2.6 million years ago. That's what we call the Quaternary or the Pleistocene. And then the glaciers have carved it. And this country has more carved valleys and glacial features than probably any other place, maybe the Alps or the Himalayas. And then but during those last 50 million years, you had deposition of sedimentary rocks off of the coast. And those became the oil and gas-bearing rocks that are still off of the coast of Norway that is creating huge amounts of money, a lot of krona in the country there, and it's helping the budget of the country. And so that's the history of the rocks. What do those rocks look like? This layered type of rock is called gneiss, G-N-E-I-S-S. That's high-grade metamorphic rocks. I have a t-shirt that I wear into Fred Meyer's all the time. It says, "Have a nice day," G-N-E-I-S-S. And the people will say, "Have a good nice day." No, it's nice, high-grade metamorphic rock. I never miss a chance. I have a bumper sticker, "Have a nice day." I mean, it is absolutely wonderful. You can imagine what we could do with another metamorphic rock, schist, and some of these. And so a good portion of the country looks just like this. These are layers of black and white minerals that have gone through high temperature, high pressure, and the insides of the mountains during the Caledonian orogeny, and then have been exposed through erosion. Here are two of my kids at a gravestone, and that it is a beautiful piece of gneiss, or it's a nice piece of gneiss. And then the rest of the country has lots and lots of granite. And I think everybody knows what granite is because many of our tombstones that we have today are made out of that. And so that is the majority of the rock that you have in the country. And when you are along the coastline in Norway, you look down here, you can see gneiss, gneiss, gneiss. And then there's a granite, and then gneiss, gneiss, gneiss. And so that's what the whole country happens to be. So that's your lesson in rocks. So how about the climate? It's amazing because of the Gulf Stream, which comes up along the east coast of the United States and then goes across past Iceland and then to Scandinavia. It just really modifies the climate. Iceland has a very moderate climate, as does Norway. You go up to Trondheim, way at the north, up in the Arctic Circle, and it has milder winters than New England in the United States, especially this week. I mean, it is incredible, and so all the Scandinavian countries have been very, very lucky because of the Gulf Stream that we have got. Interesting, comparing the precipitation in Oslo to Portland. We normally get 37 inches a year, they get normally 27 inches a year. This last year, very, very dry. I was in Iceland, and Iceland which produces huge amounts of hay. They were making huge amounts of money because the hay crop in Norway was awful because it was so dry. And so most of that hay was going over to Norway. And some of the physical features that dominate this country, first of all, high mountains that you see everywhere. The highest mountains are these two, and I'm not going to repeat them, but they're part of the Jotunheimen Mountains. And I got a chance back in 1975 to go up into the Jotunheimen Mountains and travel around and see many of the glaciers that are up in that area, and I'll show you a couple of those coming up. Also, you have the fjords. Sonia Fjord is the largest of those, but these are very deep valleys that were carved out by glaciers, U-shaped, and very, very steep sides, and that's what makes Norway so, so beautiful that you've got. And lots of islands. I mean, the whole coastline is one island after another after another. 150,000 islands that are found there. And I'll show you some pictures of those coming up here. And then I mentioned North Cape, which is up there at the northern part. Also, the glaciers are found up in the mountains, and these are moving masses of ice. I'll talk about these in just a second, because I've been studying them ever since 1972. But there are over 1,500 glaciers in the country, and so they are very, very dominant because you have high mountains and you have a lot of precipitation and a lot of snow. Jostedalsbreen is the largest glacial area that you find in the country. In 1975, I had a little sports car that I was driving around, and up at the pass, at the highest pass of the, just right next to the Jostedalsbreen Snout Glacier, my car broke down. And that was another story, which I won't go into, trying to get it fixed. Lots of rivers in the country, but most of them very, very short because the country is not very, very wide. But lakes galore, 160,000 lakes that are found in the country, and they're everywhere. And waterfalls, absolutely beautiful as you go up and down the fjords. So here's flat. Here is the southern part of Norway, and it is flat. That's out in the Jarl area that you have got. All right, so let's talk a little bit about glaciers. And so the first three pictures are actually from Alaska. That's where I started my career in working on glaciers. So I spent the whole summers up there on the Juneau ice field. And so I am roped up to this guy here. This is Canada, this is the United States. This is the Juneau ice field up here, and this is what all of Scandinavia looked like during the glacial periods from 2.6 million years ago till about 12,000 years ago. What is a glacier? Here's an example of a large glacier, a glacial valley. Norway doesn't have the beautiful glacier valleys like Alaska does. This is also this is the Gilkey Trench up in Alaska. But the glacier is a moving mass of ice. What happens is every year the snow will come in. If it doesn't melt in the summertime, it will be compressed by the following year's snow, and it will eventually become ice, and then it will fill up the tops and the sides of the hills, and then it will flow. And that flowing mass of ice is called the glacier. And Louis Agassiz, the famous Swiss geologist, is the guy that came up with this particular idea. And this is what I looked like back in 1973 as I went off onto the glaciers in Alaska, and I spent the whole summer. You didn't want to see what I looked like as I came back off of that, because it was 7 weeks without a shower. But it was a fun time. So this is actually a glacier from Spitsbergen. And so you have a big mass of ice that's coming down into the ocean. So this is a tidewater glacier. It's carved out this particular valley here. And then you have what we call a lateral moraine of sediment that has been deposited as two glaciers have come down together. So you've got lots of these in the country. If we go back to the time of the glacial period in North America, we had all of Canada was covered by ice, and it came down into the United States. Got as far as Wisconsin in the last major glaciation. You look in Europe, here is Norway, there is Sweden, there is Finland, northern Germany. It was all covered by a huge continental glacier that was coming down from up in the north, and it was also out in the ocean too. It went all the way, the glaciers all the way went over to England, covered most of England, as you can see there. And so as it was moving down, it was eroding at the bottom and picking up a lot of the sediments and then carrying those sediments down, and especially in the fjords. If we get up onto the top of the glaciers, this is what it looks like in the area above what we call the snow line. You can actually ski in the summertime in that particular area there. Now, when you put a lot of glaciers, and some of these were 4 and 5 miles thick of ice on top of the earth, what's that going to do to the crust? It's going to squish it down. And so the crust will go down. But then, when the ice melts, what's going to happen? The crust is going to rebound. It's what we call isostatic rebound. And this occurred in North America, and it occurred in the Scandinavian countries. And so here is a map of Canada, and you can see what is the famous Canadian company?
Hudson Bay.
Hudson's Bay. Hudson's Bay, 100 years ago, had trading posts, maybe 150 years ago, right here. That whole thing has moved up. That is 100 meters. 100 meters in elevation. Most of those trading posts that were there 150 years ago are now 20, 30 miles inland. The whole area has risen up. The same thing in Scandinavia. Right here, where Finland and Sweden come together, that has uplifted 100 meters also. 100 meters in that particular area. So the whole of Scandinavia has been uplifting since all of those glaciers continental glaciers have eroded. But then in the mountains here, you still have mountainous glaciers that are still there today. And then you had valleys. And the valleys were there before. The glaciers filled them up, and they would erode faster in the valley bottoms than they were on the sides of the mountains. And they would accentuate those valleys. And you would take a normal V-shaped valley, which is carved by a stream, and then what will happen is it'll erode on the sides more and create a U-shaped valley. So anytime in nature, when you are any place in a mountainous area and you see U-shaped valleys, Mother Nature is shouting out to you, a glacier occupied this. Go to Yosemite, and you have that big, beautiful U-shaped valley. You go to the Alps, and you see the same thing. So I'm going to show you some of those U-shaped valleys coming up. Now, what happened is, during the glacial period, sea level was 300 feet lower than it is today. And so those glaciers filled these valleys at that particular time. And then as the ice melted, what happened is, you had first of all, isostatic rebound, but you also had sea level rising, and it filled those valleys that originally had all of the ice in them. And so a U-shaped valley at the edge of a mountain range that is filled with seawater in it is a fjord. Yeah, and so we have lots and lots of fjords that we have down here. So here are some of the glaciers that are there. All the glaciers in Norway are receding. I mean, that is a very, very good example of climate warming. And in fact, they are the best examples of climate warming because it takes 10 to 15 years for them to respond. And all around the world, almost 85% of all the glaciers are receding. And then there are 10% that are just staying the same. And then 5 are actually advancing, but that's another story. It's related to more snow coming from greater evaporation in those local areas. So here is a nice small little U-shaped valley here. There's the glacier coming down. This is the Nygard Green Glacier, and then this is what we call a glacial moraine at the front of it. And then this is all, both of these are up in the Jostedal Green area. This Briksdal Green. Here's the glacier. This is actually a snowfield that is down here at the bottom. Look at the color of the water. It's all turquoise. And that's because as the glacier goes over the bedrock, and there's rock in the bottom, it will grind against the bedrock, and it will grind it down to silt-sized particles. Those silt-sized particles will go into the water. As the light shines in it, it bends it to the bluish, greenish end of the spectrum, creating that turquoise green color. And so, especially in the upper parts of the fjords in Norway, you're going to see a lot of colors that are very, very similar to that. Here is my favorite place in Norway. This is Trollstigen. This is the Trolls Road. I think there are 11 different switchbacks that you go up, and many of the buses will take you up this particular area and look down them. But look at this beautiful U-shaped valley that is down here, showing you that that was filled by glaciers in the past. And I have another one because I just love this place here, showing you the whole area around. It is quite a climb. I remember the first time I went up that in a bus, it was something else. But probably the best photos that you're going to see of all of Norway are all the fjords. And they are just absolutely gorgeous. These beautiful U-shaped valleys with very, very steep sides filled with the seawater. And it's an easy way to get around in them. You can see that there's a boat that has just passed down here. There are a couple places like this that you can actually go onto it and take great photos looking down on it. So I've got probably 15 photos of fjords just because I absolutely love it. And so a lot of the boats and all the cruise lines will go up into all of the fjords that you see. People love to get out on the ledges. Not always a great idea. I can tell that these are all metamorphic rocks that we have in there, and they're very strong, but not a real great idea. But lots and lots of great fjords to go through. And these ones I have no idea what the names are on those, but the rest of them I do. This is Hardanger Fjord, a very, very commonly visited one that we have got, a very, very large one. And then Sonja Fjord is the longest of all of them, and it just keeps going and going and going, and absolutely beautiful in that area. Geological Fjord is one of my favorites that is here. I love the views, especially if you can get up to the top, and there are some roads that will do that. And then you can see the boats going down in the lower part here. Sometimes people say, oh, I hate going up the fjords on a rainy day. Those are the days that all the waterfalls are just completely flowing. And one of the days that I was there about 10 years ago, I mean, we counted like in 1 mile, like 80 different waterfalls just coming down. It can be very, very spectacular with those very, very high walls that you can see on the, and again, metamorphic types of rocks, and then some granite that make them up. Here is the queen of the Granger Fjord that you've got there. Another one, Norøy Fjord. This is from a boat going up through there, and then I got 3 of them. This is from a little town of Baka. And so a lot of these boats will put into the small villages. Now, these villages are at sea level. This is going to be very important because a lot of my friends work with landslides that occur in the fjords, and I'm going to come back to that towards the end. because it is a big deal. If a landslide comes into a fjord, what happens? You have a tsunami. And you'll have big waves that will go up and down and wipe out the villages and kill a lot of people. And so it will show you what the government is doing. We're using geologists to figure that. And then, again, the same fjord here. Absolutely beautiful area. You'll notice not a lot of flat land except along the fjords. And so there are not many places to live. Stekkensen fjord that you see here. Let's see, I think this is maybe my last fjord that we have got. Allen's. Oh yeah, no, this is one. Isn't this a neat area? Neat picture. All right, so I have rated. So I've had a chance to visit the 4 areas that have the greatest fjords in the world. So down in, for instance, in New Zealand. So I'm going to be there in 3 weeks, leading a group there. And incredible. Milford Sound, Doubtful Sound, absolutely great. The whole Alaskan coast and the British Columbia coast has got lots of fjords there. Those are absolutely beautiful too. Tracy Arm Fjord, etc. You got there. And then Iceland has got east side and the west side. The west fjords are probably the most beautiful there. But I think of all of the places in the world that have the most beautiful fjords, Norway is by far the most beautiful, and I showed you quite a few slides there. Hopefully you will agree with me on that. So let's go up into the mountains, the Jotunheimen Mountains that you have got. You get up above tree line, you got beautiful small little plants in the summertime, and so you get down on your hands and knees. We call it belly botany to see the tiny cushion plants that are living up in those particular areas. Also, I've got some pictures of the coastlines and all of the islands as you go up and down the coast, because it's a lot easier to build bridges across these islands than it is to have roads right at the base of slopes where you may have big rockfall problems and landslides coming down in those particular areas. This is the Alness area, and again, look at all the white rock. A lot of granite that you have in this particular area here, and then these are all metamorphic rock. Oh, you can see the gneiss right there. So, a lot there. And another coastal area, they use every inch, as you can see, to build all of the buildings in those particular areas. The good news is it's good, stable rock. It's nice and granite, which is a very, very good rock to use for building on. And then this is another cute little village here. These are all fishing villages that are there. And lots of fishing going on up and down the coast. Helgeland coast, not as many people living in this area, but it's a great area to ride your bike in. Also rivers and waterfalls throughout the country, because you have all the snow falling in the wintertime. You have the glaciers that are melting, so all of that water is coming down into the rivers, and absolutely beautiful as you travel throughout the country, seeing those particular areas there too. So how does the environment affect the professions that we have in the country? Well, I mean, you have 2,000 miles of coastline, so fishing is huge. So cod is the #1 thing, sardines, and my favorite, herring, pickled herring. I mean, you are real Scandinavian if you like pickled herring. Now, lutefisk, that is a different story. Also, sailors. So many sailors that you have in the country, because that is the easiest way to get from town to town to town in the merchant fleet, taking a lot of the things from one place to another, boats to the main place. Petroleum industry has now hired a lot of people since 1966. I will summarize this in a second. But it is amazing how many people are involved in the petroleum industry and making things for the petroleum industry, very important. Also, as you go up north, you've got a lot more forests, so you have the pulp and paper industry that is very, very popular there too. Farming, only 7% of the population is involved in that. Why? Because only 3% of the land is good for farming. And so there isn't a lot of flat land, and actually a lot of that flat land is hay farming and then grazing that they have got. Tunnel building is a big deal here. And as I mentioned, on that railroad that goes between Bergen and Oslo, 184 tunnels were there. And I was just amazed because I was there for a 2-week field trip from one end of the country to the other, studying landslides. So I was working with all of the landslide specialists there. And you're going to see some pictures of landslides and how they use them. But all of them worked for the highway department. Because they had to put the roads through different areas, and landslides because of all the steep slopes, big deal that they had in that area. Also, where do they get their electricity? Hydropower. They have lots of dams, and in fact 100% of the power there is from hydroelectricity. Tops in the world of amount of electricity per person compared to all the other countries in the world. And it is clean energy that they have got there. Now, with all they have a lot of extra energy because they have enough to supply all of the people with electricity in the country. They have extra there, and so they can use it for a lot of their ores and melting aluminum and iron ore and things like that. We used to do that here in Oregon. Every one of our dams, as you went up to Columbia, from the Bonnyville to the area, etc., all had aluminum plants right next to them. Why? Because they had cheap electricity. And so they would run the water through the dams at nighttime when nobody was using them. They used that to run the plants. Well, now the price of electricity has skyrocketed for them. And all of those have closed down. But here in Norway, still a lot of the plants. You can see all of the aluminum, copper, nickel, zinc, titanium, and iron are there. Also, they produce a lot of fertilizers. Fertilizer needs, they get the nitrogen out of the atmosphere. But then they have to use an awful lot of electricity in order to make nitrogen-rich fertilizers that are there. And most of those ores are coming from up north. The only one that they have to bring in is aluminum, and that comes in primarily from the Caribbean. And then transportation and trying to get around the country, tunnels are everywhere, and I mentioned that before. The good news is tunneling in hard rock is very good and easy, and you can use tunnel boring machines, just like we used here as we put the Westside light rail tunnel in there. But ours went through basalt bedrock, but it was highly fractured, and it kept on getting slowed down as all the little particles kept on getting caught in Big Bertha. And so our basalt is not really perfect for that, but theirs is very, very good. And as I mentioned, lots and lots of boats there. It was interesting in researching this that the very first polar flight to the United States actually was Scandinavian Air System, SAS, to the United States, and they did one to Japan and one to the United States. Now it's standard of practice. If you fly to Europe, you fly the polar route, and that was related to transportation. Along the coast, my God, the bridges are incredible. Good solid bedrock, as you can see here. Now this is all crushed rock up in here. Now this, you'll see a lot of tunnels like this, and you say, oh, they really didn't carve through that. No, the reason is this is a landslide chute here. And so what you do is you map out the landslides, and you got to have a road there, but you don't want anybody to get hit. And so you put a tunnel there, and so the landslide will come down over the top of it and go out into the bay or wherever, and not affect the people who are on the road before. And so it is much safer to get around in those particular areas. And so there are highways heading along the coast. Now, this is an area here that has huge rockfall. So rocks are falling off of the very, very steep slopes up here, and so you have this huge berm. We use this approach here. If you go up the gorge, you will see a lot of these berms that are here, and the rock comes in and gets caught. This is what we call a Ritchie ditch that is over there. And then here's another one here, the road going up here, and they got a big, huge berm there to catch the rockfall that is coming down and protecting the road that is over here. So these are things that I see as an engineering geologist, wherever I go in the world, is how are they dealing with the potential rockfall and landslide problems we have? And Norway has huge landslide rockfall problems, and these are some of the easy things that they do in those particular cases. And so they get out there, they map, this is an area where a landslide continuously occurs year after year after year. And then there's another smaller one that occurred in the past year. And so they have to do something in this particular area when they put the road through that particular place. Here's another one. And you can see up in here, there's a little remnants of a glacier. It looks white, but see the gray in there? That's ice. And so there's water coming down periodically. And so therefore you've got to have a deep drainage system in here to capture the water, but then also you have an avalanche shed down here, because in the wintertime they get snow avalanches that are coming down. And those are also a type of landslide that you have to be worried about. And so you build the shed there, and you can drive through there any time of the year and not have to worry about the problems. Here's an area that has debris flows coming down in through here, and what do? They build a big berm here, and it just shoots around the side, does not come down and hit these people here, and it keeps the road open in those particular cases here. And another place, this is the source of a big landslide, goes down and they divert it off in that particular direction there. And here's another place here that, now there's no road down here, but they mapped it out in that particular case there. Here is a snow avalanche. They just, it came down across the road. You can see it kind of wiped out the guardrail that is there. But that's all snow. And then what they do is they come in, put the snow plows in, and open up the road in the future. But they know it is in a place that has snow avalanches quite a bit, and therefore they need to keep that open. Now, an interesting thing that is developing there, and I've got some good friends who are Swiss, and they've teamed up with the Norwegians, who are very, very good geologists, geotechnical engineers, and engineering geologists. And so these are the fjords. So here's the Geiranger Fjord here. There's Aknes, which is a little village that is down here. And very, very steep walls. But up at the top, as I mentioned before, what happens if you have a landslide that is generated up in this area, comes down into the water and creates a tsunami? That tsunami is going to go up and down the fjord and wipe out the villages. That is a big problem. You don't want that to happen. Now, they have mapped all of these out. And it is incredible, the areas where it is starting to start moving. So this is in another area. This is up in this area here. You can see these are areas that they are monitoring right now. All of these areas that have scarps. We look for the scarps, and I'll show you a scarp in a second. And then they actually have what we call monitors that will measure how fast they're moving. And then they have laser beams that are shooting in. And if it starts moving at a consistent rate, or if it accelerates, they completely get everybody to higher elevations down in the bottom of the fjords, because that may come down. So here's an example here of an area. These are targets right here. And so the lasers on the other side beam back and forth. And this is the scarp of the old landslide. See, it goes right up in through there, over in through there. And so that is an old landslide that is waiting to come down the slope. But you don't want it to come down, because you're going to have a mini tsunami. And so they are monitoring all of these all over the country, above all of these fjords. Here is another one that you see. There is where it's breaking away. And it's starting to move down. These are the two places where they're beaming the laser beams in to see if they are moving. You can see the cracks here. As this whole thing is going to fall off. I mean, that is straight down, and it's going to be problematic. There's as much water at the bottom, it's mostly a stream there. This is what it looks like on the ground when you're at the top, and I couldn't believe it when we were up there. I mean, I wouldn't want to be that guy. But he went out there, and so you have all of these from one. So all of them have been mapped out above all of the fjords. We know where they are slowly moving and creeping along. And then if something comes up, then they will get the people away from the seashore. So taking people's lives in the hands, that's what a geologist and engineer are trying to do. Now, back in 1966, they found oil and gas off of the coastline. Unbelievable. Completely changed the country. Completely changed it. And the interesting thing, only 1/6 of the actual oil and gas is used in the country for gasoline and the heating houses and things like this. And so they have a lot to export. And so therefore they have a huge amount of money coming into the country. Used to be this country had very, very high taxes, just like Denmark and Sweden, up in the 65% income tax. But now with this, the taxes are greatly reduced, because they have all this additional money coming in and taking care of those 5 million people that are in the country today. And so it's it. Now it's interesting, you would think that, I mean, it's all territorial waters of Norway, that they would take the oil and the gas from the wells that are out there and take it into Norway. There's a huge trench off of the coast. And they can't. So all of the oil actually goes over to Scotland. There's a big pipeline that collects it all from all of the wells and goes over to Scotland, and that's where it goes ashore. And so the half of the geologists that worked for the companies actually are in Scotland instead of being in Norway, who are working on those ice fields. So now what I'm going to do is just for a few slides is take you to Spitsbergen, because some of you didn't maybe hear my talk that I gave last year or the year before about Spitsbergen. That archipelago is called Svalbard. The largest island is Spitsbergen. And that's where you find polar bears. You don't find any polar bears in Norway. But up there in Spitsbergen you do. And it's an unbelievable place to go. And I got a chance to visit there a few years ago. And so glaciers galore. Coming out of these islands, and most of them tidewater, so they're melting and going into the ocean. And so we got a chance to take one day just going around seeing glaciers and then seeing the coal mining of the Russians on the other side. Now, the geology there is completely different. It's all sedimentary rock, and it's fairly young sedimentary rock. And the black lines that you can see going in through these areas, that's coal. And it's a major, major coal mining area that I'll come back to in just a second. And so very, very beautiful area. Here's the major city. This is Longyearbyen. John Longyear, American, in New York City, went over and explored the place, and he opened a huge coal mine. And therefore, they named the town Longyearbyen after him. The airport is right over here. The college is right down here. This is the power plant that you have got, fueled by coal. And then most of the city is right down here, and then people live up this particular valley here. And it was fun to kind of visit there. There is downtown Longyearbyen. And in the wintertime, there isn't any sun for like 3 or 4 months. And so it is dark the whole time. The interesting thing is, you know, I showed you the polar bear there. You always carry a rifle with you because the polar bears will come into town. And kids that walk to school all carry, somebody has got to have a rifle with them just in case a polar bear does come by. This is the Northern Lights. I love the Northern Lights, and I got 3 photos, 2 coming up. Here, my wife Glenda, and then Tom and Dorian. When we were visiting there a few years ago, we were staying at the hotel. The one hotel down there called Base Camp, and it was kind of fun. And then they also have a university there. And so a good friend of mine, Jan Larsen, is a professor there. And so he invited us, and we spent the time with them. And you can go and study a whole bunch of different subjects, their geology being one of them. Here's the remnants of the coal mine that John Longyear had just outside of Longyearbyen. It's all closed down. So Americans don't, and Norwegians don't mine coal there. But on the other side of the island, they do. And these are fossils that you aren't going to find in Norway. Look at all of these crustaceans that you have got. You've got ammonites, and you've got gastropods, etc. And because these rocks are much, much younger. Then we went over to the Russian side because going back to the treaty, many, many years ago, it said Norway will take over, run the country, it's Norwegian money, it is Norwegian language, the schools are all in Norwegian, but other countries can be there, so Russians opened a huge coal mine. And so here is Barentsburg on the other side, so we visited over there. Everything's in Russian, you know, you be a good coal miner. And here's the coal mine. And you can see all of the coal that is coming out, and it goes into ships that are shipped back to Russia from there. And here's our guide, and this is the town where all the coal miners were living. I love the Northern Lights. I've had a chance to see them up in Alaska. I've seen them on ships coming across the North Atlantic. And it is absolutely wonderful to see. And any of the Norwegian countries, especially in the wintertime, you can see them, especially if there are a lot of solar flares. And so you can see. And they change. They just completely change through time. So, the last thing I wanted to show you was this incredible landslide. There have been other ones like it, but nobody has ever photographed one. And this is a great Rissa landslide that occurred just on a very small arm of the Trondheim fjord. It was about 30,000 meters of land that just kind of flowed down into a lake at the edge of the fjord. And these are what we call quick clays. So the glaciers had a lot of water coming out of the front of them, a lot of fine-grained material from that was generated with a lot of clay in it. And they have a certain type of characteristic. They're called thixotropic. And so most of the flat land in Norway, in the fjords, is this type of clay. And then what you got to be very careful that you don't vibrate it and start it flowing, because once it starts flowing, it just continues. And that is what happened in Rissa. I'm going to show you this in just a second. 40 people lost their farms in one day. And you could just see farm after farm just flowing down on something that was solid ground in the morning, and in the afternoon it was not. 5 to 6 million cubic meters of soil went down in that. That's what we call a quick clay landslide. And so I'm going to show you my final slide tonight. Here's a picture of what it looked like. These are all the houses that floated down. That was flat land like this, and it just kept on sloughing off, sloughing off, sloughing off, and flowing away. And this is what the quick clay areas look like there. And we also have some quick clays also in Canada along the St. Lawrence River. And so this is going to be my final slide, but I'm going to show it to you so I can switch over to the other thing. And there, this is going up the troll road. There's the troll that you see there. So let me get out of this, and let's see if I can bring up this other one. Well, maybe we can. Let's see. How do I make that big? Right there. Let's see if we can get the English commentary. Let's see. Well, you know, but I know this thing because I've watched it hundreds and hundreds of times. And so I will narrate instead of this beautiful British voice that is talking about this. So this is the community of Rissa. So quick clay landslides are something that are most famous in Norway. And so during the glacial period, you had ice that was up to 5 or 6 miles thick, covering the whole area, as you can see here. And so we're going to focus in right down at here. Well, it'll be up in this area here. And so as it retreated, as the ice retreated, you had more and more melting of the ice, but then you also had the movement of all this clay and silt. Silt is mostly silt with some clay in it, but we call it quick clay. And so here are some of the glaciers. And so they melted, and so today in the country we have all these flat lands that are there. I can't remember what he's saying now. So here is this valley. And this valley, very, very flat, but it has all of these thixotropic clays, quick clays in it. And then we will see a farm in just a second where they did a little excavation. And this was all taken with 8mm cameras. And the guy had just gotten the camera. And so for thousands of years, so the glaciers left this area 8,000 to 10,000 years ago. And every time it rains, that water goes down through the ground, and there was a lot of salt in this because all of this clay was deposited in salt water. And then it dissolves the salt leaves, and so here's this thixotropic clay. When you put a weight on it, look what happens. And that's what happens. Or if you vibrate it, it will just turn to liquid. And so this solid ground, just in one day, completely turned to liquid because all of the salt has been removed. But magic, if we take that and put it in here, and then we shake it with salt, and he's going to do that in just a second, mix it up, it will turn into a solid again. And so here he goes, look at this. And he will turn this into a solid. And so this is a type of clay that we can determine, and we teach in our soils classes how you determine if you have a thixotrophic clay. And so British Columbia has some places along the St. Lawrence in Canada, Norway, and some places in Sweden. Look at that. Solid afterwards, just by adding a little bit of salt shaker to it. So now we're going to go out, and he's going to show you where exactly along the coastline this is. It's very close. There's Rissum. Very close to Trondheim. There's the Trondheim fjord. And remember, all of this was taken on an 8mm movie camera. So it is not the sharpest. But we have it, which is incredible. And here's this flat land in the bottom of the area. All little farms you can see around here. And we're going to have a little farmhouse over here in just a second. Tell me it's over here. Oh, no, it's here. So there's the house. The barn, the house. And he dug a hole over here next to his barn. And he dumped all of that soil over here on the slope. And this is the lake. This is a big lake, okay? Not a thing to do. You're adding weight to the slope, and therefore it may start flowing, but these are thixotrophic clays, and then all of a sudden it started flowing. And then it got a little bit bigger. And then it got a little bit bigger. And yeah, that's 1 hour.
1 hour.
1 hour. About an hour after they put this over here. And then this is where the photographer with his new Super 8 movie camera came in, and here he's looking at the scarps over here. And look at how much is already indented. And then all of a sudden the land will just kind of fall in. Look at that.
So what is the total relief of that scarp?
Oh, the relief was about 6 or 7 feet. And then you have a wave coming as that material goes in, and then the water comes down like this. And all day long, that slope retrogressed back in there. And you're going to just see more and more, and then all of a sudden it's just going to go wild. Yeah, see there it goes in, there's another piece going in. And that's his farm. And then here comes another wave. Another one crashing down in. Another one. Nobody had ever witnessed this.
So it says finely sorted, very uniform particle size?
Yes, it's half clay and half silt. It's very fine grained silt. So yeah, it's very well sorted. Look at that whole thing just go. And then at that point, all of a sudden, if I'm not mistaken, this whole thing goes here. And he says, gotta get out of here. Yes. So he didn't get any photos there. Somebody had a question.
Do they have property insurance?
You know, that's a very interesting country. Remember, the Scandinavian countries are very socialistic. And so the government is going to come to your rescue in the end. And I imagine that they did. But look at that whole thing, just all went. So he moved over here, and then it continued there. And then Here's another farm, which was up there. And I think it's that farm right there. It went. And then this one, which was in the back, I think it was over here, it went. And it just slowly worked its way up the whole valley that day. One farm after another, after another, after another, disappearing. And now, so you see all of the buildings floating by. Yeah, how did only one person die? And they went out, the police went out and said, get out of your house, you have to evacuate. Why? Because this thing is happening. I mean, they didn't know how to describe it.
So the reason that regressed so far is there was a lot of storage in the fjord. The fjord was deep, and that base level could cut all the way out.
Yeah, actually this is only about 15 to 20 feet deep. That is actually flowing down. And so, but the upper part is all this type of clay.
How come it didn't form a delta and stop?
Well, eventually it did stop and it did form a delta of this material out in the lake, so that's a good point.
How long did it actually go on?
All day.
24 hours?
Yeah, and then eventually it came to a point where it stopped. And I'm just going to stop this in just a second, because it's just more of the same, more houses, more barns coming by. Actually, they went in and took all of the cattle and cows out the street.
Has the land around there continued to erode?
Yes, it did for a certain period of time.
How much is that like the West Hill silt?
That's always a good question. The West Hill silt has very little clay in it.
What happened to the neighbor who caused all of this?
That's a good question because they didn't know what to do with it. This was something new. And now you've seen one of the most amazing landslides, RISSA landslides, and it was filmed there. And so we show this to engineering, geology, and geotechnical engineering students all across the world because it's unique. So when I got to Norway, when we did this landslide thing, I said, "Are we going to go to Rissa?" And he said, "Of course." So we did. So I even have samples of soil from them. So that is the story of Norway. You saw some neat photos. It's a great country with a great geological history. How many of you have been to Norway? Yeah, wow. How many are gonna go to? I love it. Pickled herring and glaciers and fjords. Life doesn't get any better. So with that, I'm going to say thank you. Are waiting, but if you have 2 or 3 questions, I will answer the questions right here. Dave and I went to high school together. He bagged my mom's groceries at Keno's.
Mom was my favorite customer. She was a sweetheart. Anyway, she drove a 55 Chevy station. Anyway, the question is, with all the resources, what did the average Norwegian use to heat his home?
I don't, that's a good question, but I'm sure fish has been a major part of their diet for a long period. But and mutton and cheese.
No, I said, how do they heat their home?
Oh, heat their house. So first of all, they had lots of hydroelectricity, and so I bet you that most of the houses were heated with electricity. But that's not as efficient as gas is, and so once they produce huge amounts of natural gas in the gas field there. So probably it is a shift over here. Question back there.
Do they sell a lot of electricity elsewhere?
Yes, they do. They sell electricity and then the oil and the gas. And so they have, those are their three big, well, and then all the herring and all of the fish and the cod, so they have a lot of exports. You know, only 5 million people there, and they're generating a huge amount of exports, and you know, it's wonderful. Yes?
It sounds like they've developed a really great system of telling if a landslide or an avalanche is about to come.
Yes?
And presumably then they have some education for people on the other end, so there's actually a plan of what to do if the bell goes off.
Yes, if you live in that fjord, they have sirens, and they also have, everybody has a cell phone in the country. And so,
Steep slots.
well, what happens is when a landslide starts going, it will, we have a laser pad on it, and it will start moving and moving, and it will, they all creep. But if they start accelerating, and it creeps at a faster and faster rate, we know what that threshold is that we tell people to get out and get to higher elevations. And so, very, very important. Yes?
The landslide up above the Stilbovish River, there is still Arlington area a few years ago, was that?
Also, yeah.
Was that like that kind of a landslide?
No, completely different. One of the most unique landslides in North America and the world. And it was all glacial deposits that were deposited up there. And it was amazing when we went in afterwards and we looked at LiDAR of the valley, we said, my God, there have been hundreds of landslides that have occurred in the past, and we didn't know that. And it was a past history. And then so the state of Washington passed a levy. They hired 7 geologists. And so Stephen Slaughter, a good friend of mine, now runs that program up there. Kate Nicholson, one of my old students, is #1 person there. And they're mapping all of western Washington for landslides. They said we don't want OSO to occur there. In Oregon, we're doing the same thing. Bill Burns, another one of my students, is in charge of that. And because we understand landslides now. And so we don't want them to happen. We have time. We have 4 questions right there. 5. Right there.
There was another slide up in Washington on Whidbey Island, which is a lot of clay and not as big as Oso. But are you acquainted at all with that one?
Whidbey Island has them over and over and over, and so do all of the islands that are up there. Most of those are glacial deposits, glacial marine deposits, and they do have clay in them. And every one is different. And as you drive, you take your boat through the Puget Sound. If there's no vegetation on a slope, it's had a landslide, and it's active. And so those have all been mapped. Maury Schwartz, professor at Western Washington, did that, and very, very dangerous. We understand those. You don't want to put water onto the slope above. Right there, another question right there. Yeah.
Thank you, Scott.
Thank you, Osa.
You mentioned that when a glacier retreats or melts, that the earth bounces back. I don't know the technical term you use.
Isostatic rebound.
Isostatic rebound, I love it. Is that still happening? Is that still happening?
Yes, it is. It is still happening.
Where?
All over Canada and all over Scandinavia. They're still monitoring and it's still rising up. It's amazing. It's slowed down, but it's not as fast, but it's still happening. Yes?
Why did the Germans want to go up into Norway in World War II? They were on...
Interesting story. They love to hide their submarines in the fjords. And that was the first thing. And so the Danish and Norwegian undergrounds were very, very strong. And Norway declared itself neutral until the Germans came in and took them over. But the Germans were all their U-boats were all hiding out in the fjords. And so that was the major reason that they wanted, the first reason that they were there. Good question. We have 2 questions right there.
Yeah, I'm curious about the Caledonian orogeny specifically. I mean, if it's granites and gneisses, that's all sort of intrusive, very felsic. So was that decompression melting above the subduction zone? I mean, it wasn't a Himalayan.
I love it. So what happened was that same orogeny created the Appalachian Mountains.
Okay.
And so it uplifted all of those mountains at the same time, and it went all the way up to Greenland and across Scotland and England and up into Norway. And then so those were all at the heart of the mountain range. All the mountains have 400 million years old, they've eroded away. And so what you have got are the heart of the mountains that you have there. You go up to the Canadian Shield. And it's all gneiss and schist and granite. Why? Because it's the heart of an old mountain range that has completely been eroded away. One last question.
So I'm wondering about, is there seismicity associated with the isostatic rebound? And I'm guessing probably not, because it seems like that would have created 100 or 1,000 worth of landslides.
So very, very little seismicity because it's occurring very, very slowly. So we're looking at 100 meters in 10,000 years. That's very slow. So that's a good question to end on. I'm going to turn it back over to Osa. Thank you very much, or I should say, Tusen Takk.